Hey everybody. Okay, today we're going to be covering ratios and proportions. And so we'll start off with a quick review of what a ratio is, and we'll talk about proportions, and then we'll get into some examples. So a ratio is when you have, or when you are comparing two things. So you could be comparing like the number of trees to the number of bushes, or the number of girls to the number of boys. And when you write a ratio, there's a couple of different ways you can write it. You can write it like this. Let's say the ratio is 3 to 7. That's one way you can write the ratio. You can write the ratio like this, 3 to 7. But by far, my preferred way that you're going to write ratios this year is going to be as a fraction. And so that would be 3 to 7. And notice that it matters the order in which you write it. So 3 to 7 is not the same as 7 to 3. So if the ratio is 3 to 7, then the 3 needs to be on the top and the 7 needs to be on the bottom. The 3 needs to be the first number and the 7 needs to be the second number. That's a critical thing, is however it's written in the problem is the way the ratio needs to be set up. Okay, so that's the first thing. And so that's ratio. So again, ratios are basically just comparisons of two things. And then we also have this idea of a proportion. And a proportion is when you have two ratios that are equal to each other. So two fractions that are equal to each other. So an example of that might be something like this. 3/5 is equal to 30/50. This is considered to be a proportion right here, because if I simplify this fraction down and I divide the top by 10 and the bottom by 10, I would get the same fraction over here. So this blue problem here is considered to be a proportion because the first fraction is equivalent or equal to the second fraction. Okay, so that's a quick little review of what ratio and proportions mean. Now let's take a look at some problems. So here we have some data, and what we're going to do is we're going to write ratios comparing. So I'm going to write a ratio that compares the green dots to, the red dots to the green dots. So the order matters. The fact that it says red first and then green, then I have to write my ratio so that I do red first, then green. So I see I have 1, let me get back to my 1, 2, 3, 4, 5, 6, 7, 8 red dots. So that means it's going to be 8 over. And then green, I have 1, 2, 3, 4. So 8 over, whoops, let me go back. 8 over 4. So the ratio of red to green is 8 to 4. You also could write it as 8 dot dot 4, or you could also write it as 8 2 4. Although, as I mentioned before, my favorite way is the fraction. That's the preferred method. Okay, so then we're going to look at red to total. So if I see the number of red dots that I have, again, I have 1, 2, 3, 4, 5, 6, 7, 8. So that hasn't changed. I still have 8 there. But the total number of dots that I have this time is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 8 over 12 for that case. And again, I could write it as 8 to 12 like this, or 8 to 12 like that, but I'm just going to write it as the fraction. And then the last one that we have there is the green dots to the total. So the green dots to the total would be 4, and then I still have 12. So since it was green to total, The green has to be the top number, and the total number of dots is the bottom number. The order matters in which you write them. Okay, so that's the how we write just some basic ratios. Now let's take a look at the next part. Here we're going to solve these proportions using multiplication. So what I want us to look at here is if these two fractions need to be equal to each other, then that means that there must be some multiplicative number. There's a number that I can multiply by that'll get me from this fraction over to this one. Well, the problem is we don't know what this number is right here. I don't know what x equals, so that means I got to figure out what x is. But I can use the other information that's given to me, this 2 and this 6 and this 5, to help me find the x. So what I do is I look, what number could I multiply 2 by that will get me to 6? And so I'm sure we can figure out that I can multiply 2 times 3 equals 6, which means the bottom has to be the same number that I'm multiplying by. So it's going to be 5 times 3. So if you notice what I did here, I'm multiplying by 3 over 3. And the number 3 over 3 is 1, which means I'm multiplying 2/5 times 1, and of course we know that doesn't change the value. So I could say that 5 times 3 would be equal to 15, so x is equal to 15. So the proportion that would be 2/5 is equal to 6 over 15. 2/5 is equal to 6 over 15. Okay, so let's take a look at another one here. Now on this bottom one, it's a little bit different because the variable's in a different spot. So I can't do the top because I don't know what 10 and how 10 and t are related. But I look at the bottom, I go, oh, okay, how do I get from 8 to 4? Well, if I want to get from 8 to 4, then I could divide 8 by 2, and that would give me 4. So if I divide the bottom by 2, I need to divide the top by 2. So then that's 10 divided by 2, which would be equal to 5. So then so t would be equal to 5. So this proportion would be 10 over 8 is equal to 5 over 4. And so these two fractions are equal to each other. Okay, so I multiplied or divided this by 2 and divided this by 2, and it got me my other fraction there. So in this case, t would be equal to 5. All right, let's take a look at the next slide. All right, so now we're going to solve this proportion, but we're going to do it a little differently because what I notice here is that if I'm going to try and use multiplication, I don't easily know a number I can multiply by 5 that gives me 4. The previous slide, they were kind of easy because I could divide by a number or multiply by a number. Here, it's not quite that easy, so we're going to use a little bit different technique when the problems are not as simple and we need to solve for problems that aren't automatically multiples of each other. So what we're going to do here is a thing called cross multiplying. Now I do this a little bit different than a lot of teachers do it perhaps. So later in other classes you might see a teacher use a little bit different technique. The idea is the same, it's just the notation is a little bit different. So when we cross multiply, here's what I want us to do, and this is the notation that I expect to see every time. We're going to circle an arrow. So you're going to circle the bottom number and multiply across to the top, circle the bottom number and multiply across the top. You always circle the bottom numbers. Okay, we always circle the bottom numbers, never the top number, and then I always draw an arrow cross to the other side. That's why it's called cross multiplication. So then what I get is I follow my arrows. So on this side over here, I see that I'm bringing the 4 and I'm multiplying it times the 3. So that means on this side I should end up with 12. And then on this one, I'm taking the 5 and multiplying it times the x, which means I'm going to end up with 5 times x. And then my last step to solve this, I need to get x by itself. So I divide the right-hand side by 5, and that creates a giant 1 right there. Those simplify out because that makes a 1. And then if I divide the right side by 5, I need to divide the left side by 5. And I see that 5 goes into 12 2 times 0.4 4 is equal to x. And if you need to do that on the side, the 12 divided by 5, that's okay. I would use upwards division there. You could use long division. So 2.4 is equal to x in this case. So you can see that our answer here is a little bit different for x because it's not a whole number. You don't have to have whole numbers. You can have decimals there, and that's when this cross multiplying comes in handy. Okay, let's take the next slide. So it's the same type thing. We're going to use cross multiplying again. I'll go a little bit quicker on this one. I won't be quite as descriptive. So whenever we're doing cross multiplication, I'm going to circle an arrow. So I take this, circle like that. I take this one, circle across like that. And so on the left-hand side, I should have the 4 times 12. So that is 48. And on the right-hand side, I should have the x times 10. So that's 10x. And then I'm going to divide both sides by 4. Excuse me, no I'm not. I'm going to divide both sides by 10. Divide this side by 10. And so again, these simplify out and make a giant 1. So on the right hand side I have x. And on the left hand side, if I divide 10 into 48, that gives me 4.8 for my answer. So x is equal to 4.8. So we just did a couple of different ways of solving these proportions. When the problems are simple, you can use for a number you can multiply or divide by. As they get a little bit more complex, you might want to use the cross multiplication. All right, and the last thing is setting up a proportion. So here we have a proportion. It's a word problem. So we have 8 kids in class have blue eyes, and there are 30 kids in the class. If the school has 64 kids with blue eyes, how many kids are in the school? So when we set up these proportions, the most important thing we have to remember is that the proportion has to be set up so that the same part of the problem is in the same location. Here's what I mean by that. So we're going to have a fraction or a proportion that looks something like this. 2 fractions that are equal to each other. The first fraction is going to be the class. The second fraction is going to be the school. Okay? So when we talk about what's in this first fraction here, it's only going to be when we're talking about the class in this problem. This second fraction over here is going to be when we're talking about the school in this problem. Okay? So this is the class and this is the school. And then we have on the top, we're going to have blue eyes. I'll do that in blue. That would make sense. We're going to have blue eyes. And then we're going to have total. Because we have blue eyes and then we have total number of students. Okay, so now we can take a look at this problem. And I see that I have 8 kids in class with blue eyes. 8 kids in class with blue eyes. So here's the blue eyes, that's the top. Here's the class, which means right here is where the 8 needs to go, because that is 8 kids in class that have blue eyes. 8 kids in class have blue eyes. The next thing that we see is there are 30 kids in the class. So the total number of kids is 30 in the class. So here again is the class and the total. So that means the 30 goes right there. And then I come over to the next fraction and I see that it tells me that the school has 64 kids with blue eyes. So the school has 64 kids with blue eyes, so that means the 64 needs to go here in the school and the blue eye row. So that's going to be 64. And then the question is, how many kids are in the school? So how many kids total are in the school? That's what we don't know, so that's going to be our variable, x. Okay, and at this point, I don't care how you solve it. If you can use multiplication or division to solve it, that would be great. If you want to cross multiply, that would be great. I set it up so that we could do multiplication. So what I see here is that I could multiply 8 times 8, and that gives me 64. Therefore, I could multiply the bottom by 8. So x is going to be equal to, and 30 times 8 gives me 240, which means there are 240 kids in school. Okay? And that's how we use proportions to solve real-world problems. Okay, so make sure you took down the notes in the multicolors, and of course make sure you're adding your fifth color. The stuff that I was saying that I didn't write down is always very important. So make sure you have good notes, and I'll talk to you later.